Now we're going to learn how to factor by grouping. I, for some reason, never learned how to factor by grouping in high school. Or maybe I did, but I wasn't paying attention. But once I became a teacher, I learned about it and I love it. It's like magic, you'll see. Here's an example we want to factor by grouping. The first thing you do is pair up each of the binomials, the first two and the second two, like this. And you want to make sure that you leave this sign in between the parentheses, because when you have a negative, it's very important to put in the addition sign. So now we do have a common factor. This binomial has a common factor, and this binomial has a common factor. So we'll pull out the common factor from here, which is just going to be x, and now we have x times x minus 4. And here's the magic part. Now we want to pull out the common factor from the second pair, which is going to be 6y. And what's going to be left over when we do that? It's x minus 4 again, the same exact thing. And that's the part that I think is magic. And as long as the expression is factorable, that's going to happen every time. And then what you have to do, and this is the step that people tend to get confused about. We're applying the distributive property here. If we have x being multiplied by x minus 4 and 6y being multiplied by x minus 4, we can put the x and the 6y together in one set of parentheses, and it'll be multiplied by this x minus 4. So now we have our binomial and we factored it. Here's an example that's a little more complicated. We have a subtraction sign in the middle. And that means that when we group it up into parentheses, we need to let this negative go with the 4y, because that's the term that follows it. And then we have to insert plus sign here so that it doesn't look like multiplication. Okay, so now we've got it fixed and we can do regular factoring by grouping. The first binomial has a common factor of x, so we pull out the x and get 4y plus 3. And remember, the magic behind factoring by grouping is that we know the second binomial should match the first. So we need the second one to also be 4y plus 3. So that means we need to factor out a negative 1. Don't be confused. If this just said 4y plus 3, you need to take out a 1. Something has to come out. So we'll take out that negative 1, and now we have 4y plus 3 inside the second set of parentheses. Now we put x minus 1 as its own binomial, and there's the solution. Another complication you might run into is finding 4 terms that the first pair doesn't have a common factor, and the second pair doesn't have a common factor. Here we've got 5xy and 6uv. There's nothing we can pull out of there. But before you decide that it's not factorable, you want to try switching the middle terms. Here's where I tried to do it first and I decided it wasn't going to work. So now I'm switching the 3vy with the 6uv. Now my first two terms have a common factor of y, and my second two terms have a common factor of u. So we are going to be able to factor it. So put in your parentheses, and we pull out the y from the first term. So what's going to happen with our second pair? We know we need 5x minus 3v to be in the parentheses, and the common factor is going to be a 2u. So let's pull that out, and we've got a little problem. Instead of 5x minus 3v, I have 3v minus 5x. But 5x minus 3v and 3v minus 5x are opposites. And remember that you can change opposites by pulling out a negative 1. So now I need to pull the negative 1 out of here in addition to the 2u. And when I do that, they match up, 5x minus 3v. So now I apply the distributive property and I have my solution.